Okay, welcome to NUPOC Video Study Guide number 23. Let's look at question 20 in the General Math section of Guide 1, where it asks us to derive the quadratic equation, which I'm sure, as you recall, takes this quadratic equation here with these coefficients a, b, c, and allows you to find what x is via this equation here. And recall that this is actually the coefficient on x to the first, and this is the coefficient on x to the 0, just to be thorough. So let's go ahead and use a method called completing the square, which I'm sure some of you are familiar with, which actually is a method that allows us to find the roots of a quadratic like this by essentially kind of doing out, kind of going through and doing the same thing you would do to find the quadratic equation. So let's go ahead and get started. So the first thing that we'll do is we'll go ahead and bring our constant term to the other side of the equation, and let's get rid of any leading coefficients we have on our highest order term. So this is going to turn into x squared plus b over ax equals minus c over a. Right? Now let's take this middle coefficient here, or the coefficient on the x to the 1 term, and let's go ahead and square half of it. Okay? So what this is going to allow us to do is neatly factor this side of the equation, right? So we're going to turn it so it has a perfect square factor. So let's go ahead and square half of that. So b over 2a squared equals b squared over 4a squared. Now let's go ahead and add let's add this to both sides of the equation. So we're going to get x squared plus b over ax, right, plus b squared over 4a squared equals minus c over a plus b squared over 4a squared. So I haven't changed anything, I've just added the same thing to both sides of the equation. But now we can conveniently factor this side, right? Because this is the square of what half of this is. So, if we had, x plus 2 as our factor, and that was just a neat square factor, so it's just x plus 2 squared, let's say, in the middle we'd have plus 4x, and over here we'd have plus 4. I guess 2 isn't a great example because twice 2 is the same as 2 squared. But anyways, I think you probably get the point. So we're able to factor this into x plus whatever half of this is, or the whatever the square root of this is, right? So this would be x plus b over 2a, right? So when we take this term and we square it out, we'll get plus 2b over 2ax, right, which would just be b over ax, plus b over 2a squared, which is this term. And then, of course, we'll have our x squared term out front. So this is going to be equal to minus c over a plus b squared over 4a squared, right? Let's go ahead and get ourselves a common denominator on this side. So we can just multiply this term by 4a over 4a. So this becomes minus 4ac, starting to look a little bit familiar, right? Plus b squared, and the common denominator is now 4a squared. Let's go ahead and I'll just write it here just to, I'll kind of rearrange this just to make it a little bit more familiar, right? So 4ac and then 4a squared. Let's go ahead and take the square root of both sides, right? So over here we take the square root of x plus b over 2a squared. We'll just get x plus b over 2a take the square root of this other side over here, and we'll get on top plus or minus the root of b squared minus 4ac. Now it's starting to look very familiar. And on the bottom, we will get 2, right, and a. So 2a. Let's go ahead and move this term over to the other side of the equation. So I'm going to try to keep this to one page here. I think I can do it. So we're going to have x equals plus minus root b squared minus 4ac. I'm going to write it a little bit smaller. I hope you can still read it. Over 2a minus, right, b over 2a. We already have our common denominator. Let's move this term to the front to make it a little bit more familiar. And we will have x equals minus b plus or minus square root b squared minus 4ac over 2a. So it's exactly what we had up here, what we had written from memory. So that's how you do it. Just a quick walkthrough of deriving the quadratic equation or the quadratic formula, whatever you want to call it, from the actual second-order polynomial using the completing the square method.